Hi class, how are you? Hope you're doing well. Welcome to our lecture on paired samples t-test. Now in this lecture, we're going to talk about the background information behind paired samples t-test, what does it mean, and so forth. And then we'll hop on over to our studio for a demo. And then of course it'll be your turn to try your hand at paired samples t-test. And so very exciting stuff. So let's get started. So a quick review of t-tests. So as you already know, t-tests are for testing hypotheses about means. And last time we took a look at between subjects t-test or independent samples t-test, in which you compare the mean of group 1 against the mean of group 2. Now in this lesson we're going to talk about paired samples t-test, which is also called within subjects or dependent samples t-test, where you take a look at two related scores to see if they're the same or different using mean difference scores. So a bit more on paired samples t-test, which is the focus of our lecture today. So its purpose is to compare two scores that are from related sources. And other names for it, as you heard, include within subjects, dependent samples, or matched pairs t-test, and they all say the same thing. How did that happen? And so here are some examples of when you might use a paired samples t-test. First, you might take repeated measures of the same individual. And so for example, exam 1 score versus exam 2 score from the same individuals. Or you measure somebody using their left hand and then again using their right hand. Or perhaps you have related subjects. For example, husband and wife who live in the same household. Or two siblings. You might also have matched subjects, or subjects that are purposefully matched into pairs. And you want to compare if those two are the same on particular measures. And that's often done with demographic variables to minimize confounding effects, for example, in a clinical trial study. So they might be matched on age, socioeconomic status, height, weight, and so on. And so you can see that in all of these cases, two scores would be related. And your job is to see if those two scores are statistically different from one another or the same. And so first you compute the t-statistic. And the t-statistic compares the mean difference scores to the population mean difference. So what you're doing is for each pair of scores that you have, you take the difference. And then you average out those difference scores across all the pairs that you have. And then you're comparing that to the population mean difference that is hypothesized to be 0. And so the t-statistic formula looks something like this. And here's a little bit of information about the notation. So the capital D refers to the difference score for a pair of variables. And so these are the two scores for the pair. Take the difference. And then X bar D means the mean of those differences that you just took. And then the degrees of freedom is n-1, where n equals the number of pairs that you have. And so as you know, you and our studio collaborate together to make the magic happen. And our studio fortunately does all of this for you, and your time to shine is over here in evaluating your hypotheses. And so let's take a look at another demo. We're going to go back to the sleep data set, but here is the different research question for today. Do sleep difficulties change over time in college students? And so once again, we're working with 273 college students, and they provided ratings of their sleep difficulties, insomnia symptoms at 2 time points, Sleepy 1 and Sleepy 2. And so these were 2 different time points. And technically, in this case, the DV, which is a continuous variable, is measured twice. And so Sleepy 1, Sleepy 2 represent 2 different measurements of the same construct. And then where is the IV, right? Last time we had an actual variable, a grouping variable that was the IV with 2 levels. In this case, it's actually kind of an invisible thing. But again, we have an IV that is categorical with 2 levels, but it is defined by measurement occasions, so the time points. But it's implicit in that it's not as though you see a variable that says time point, it's just that your DV happens to be measured twice. And so that is a pretty interesting difference, that you don't see your IV in the form of a variable. So if you convert this research question into testable hypotheses, and let's take a look at the two-tailed hypotheses. Here you go. Pretty simple, right? And so the null hypothesis says sleep difficulties do not change over time. So in other words, Sleepy 1 and Sleepy 2 do not differ in their means. The alternate hypothesis says the sleep difficulties change significantly over time. And so it doesn't tell us the direction of change. It just says that those two time points, the sleepy 1 and sleepy 2, are different in their means. And this is what we'll test today. But if you wanted a one-tailed hypothesis, here is an alternate hypothesis you might derive from maybe prior theory, or maybe the concept of regression to the mean, for example, where everybody tends to regress to the mean in their scores. So maybe if you were elevated in sleep difficulties, over time you get closer to the typical level of sleep difficulties. So that might decrease significantly over time. And so here's one alternate hypothesis. The null hypothesis is the opposite, the other side, where the sleep difficulties did not decrease over time. And so this is kind of ambiguous about whether the sleep difficulties stay the same across time or increase. But essentially the meaning is that this is the situation where this is not true. They're the opposite hypotheses. Now, looking at the paired samples t-test in RStudio, once again we meet our friend t-test, but the format looks a little different. So you've got the t-test, and of course you save all of this into a separate object, so there should be a statement to the left of this that assigns a name to your object containing this t-test. And so t-test, and within parentheses there's dependent variable 1, so maybe sleepy 1 for example. And then the second dependent variable, so maybe sleepy 2 in this case. And then you would say paired equals true to let RStudio know that you're running a paired samples t-test. And then there's the optional statement about alternative. And so you can use that only if you have one-tailed test. You can leave that out otherwise. And this is very similar in logic to what you saw before, where less means that dv1 is less than dv2. Greater means dv1 is greater than dv2. And so whatever you hypothesize. In our demo, we're going to test two-tailed paired samples test, and so we're going to leave this blank because two-tailed test is the default. And then once you have that object that contains that t-test, then you just print the object. Just to recap though, what is different compared to the independent samples t-test? And so I've taken down some notes for you. And so here, instead of a tilde, where you regress sort of like the dv on iv, the two variables are separated by comma, and they're both continuous variables right here, two dv's. And then instead of the var dot equal, where you indicate the equality of variance, you have a paired statement. Paired equals true. And then this is, once again, an optional statement, depending on your hypothesis. And so let's hop on over to RStudio and try running this. See you there. All right, so here is our RStudio session. Now, I've started a new session because I want to have a clean environment. But if you already have loaded the sleep data for the independent samples t-test and I have it open, I think that's fine. Just want to make sure to check the environment to make sure that there's nothing that is awkward or odd about the way the data set and all the objects are. And so in this case, I've just set the working directory to paired samples t-test within the reference notebook, and then I have read in the sleep dataset and attached it. So we're good to go, and you can see the structure of your data frame here. And so let's try running the paired samples t-test without further ado. What should I name this test? All right. You can certainly name it however you like, but we are going to do our friend t-test. And in this case, we're looking at sleepy 1 and comparing that to sleepy 2. And then paired is true. And there's no alternate hypothesis because we're doing a two-tailed test. And so we can just leave the alternative statement blank, not put it in there, and then run this, and then print that object, and here it is. So we have the results of the paired samples t-test. Now here you get the mean of the differences, which is the large D that you saw in the earlier lecture slides. But if you're curious, of course, about the means for both groups, you can certainly run the mean function to take a look and get a better understanding of what the means look like for both. And so you can see that the mean of the difference is negative. So essentially this is the mean for sleepy 1 minus the mean for sleepy 2, and then you get a negative number. So let's hop back to PowerPoint and talk about the results. All right, welcome back. So let's break this down a little bit. So here, once again, are the t-test results, very familiar to you by now. And then down here below is the mean difference, or the large D, as we talked about. So the mean of sleepy 1 minus the mean of sleepy 2. And it's negative, which indicates that the scores actually increased over time. So based on the two-tailed hypothesis, you can now say that the level of self-reported sleep difficulties significantly changed across the two measurement occasions, but notice that this is two-tailed test, and so we're just saying that it changed over time. And then you report the t-statistic similar to the way you did before, but this time the degrees of freedom is actually n-1. So paired samples t-test is n-1 for degrees of freedom, and then you write out the rest. And again, we have a very small p-value here. Alright, so now that you know how to run paired samples t-test in RStudio and interpret it, it is your turn to run a paired sample t-test to test the following research question. And so again, we're using the sleep dataset, and here's your question. Do students' mood symptoms improve? So essentially, that means it decreases over time. And so here are the two variables, mood 1 and mood 2. And these are mood-related symptoms measured at time 1 and time 2. And the question is asking whether the mood-related symptoms go down over time from between time 1 and time 2. And so based on that, be sure to select the correct option for the alternative statement and look forward to hearing what you found out on campus. All right, hope you have a good week. It's been great spending time with you. Please feel free to reach out with any questions or concerns. Take care and talk to you soon.